right. Good morning, good afternoon, good evening, folks. Thanks again for joining for another machine learning community stand up. I'm Luis, and my co host here, nope, there we go, Jake and Bree are with me to talk about machine learning today. So today we don't have a guest. Usually, we'll have a guest, but in this case, we're just doing office hours, and yeah, we're just gonna chat about what's new with ML.net, just in general, the machine learning space, and yeah, so
and some of the stuff we're working on.
yes, some of the stuff we're working on as well. So let's get into it. And again, if you have any questions throughout this, feel free. This is going to be sort of like a super like loose like open format where we're just gonna take questions and just talk openly. But before we do that, let me get into the community links, which let me paste here into the chat. Right, there we go. At stream, and I think this is the right screen. Yes. All right, cool. So if you go over to that mlnet-stand up and go to that today's date, you should have access to all the links that we're going to be covering today. And the first one here is this use case from Camera Futura, who are using ML.net for photo cooling and organizing. So the way that I understand this is, and Bree, maybe you can expand on it, but the way that I understand it is typically, let's say that you're taking pictures, and you'll take a whole bunch of shots of this one landscape or whatever it is that you're trying to capture. And then when you get back and you're trying to edit that, right, you're gonna have to go through all these pictures to sort of find like, okay, well, which one has the nice good lighting, which one whatever it is that you're looking for, and whatever is a good picture to you out of the bunch. Right, that's a pretty manual process. So in this case, what Camera Futura does is they have this desktop application which uses ML.net to automate that process for you, so you don't have to necessarily spend the time looking through all of these pictures and trying to find what the best one is based on, again, exposure, lighting, whatever it may be, right? Whatever those conditions may be, they automate that process and make it much simpler for you to sort of do so. So if you go through this here, right, you can kind of get a sense of what this looks like. It talks a little bit about the business problem here. So kind of like what I just described, right? Trying to weed out those low quality images and things like that. So make sure to check this out, especially if you're if you're into photography and you're working with photos and you want to maybe speed up that process. Make sure to give this a look. This might be something that could help you. Let's see here. We also have this post from a few days ago from Visual Studio Magazine, which basically just covers some of the new developments in ML.net. We're going to be talking a little bit more in detail of what those are, but of course, I think the hero sort of feature or new feature in this release is this ARM device support, right, and improved support for Blazor WebAssembly scenarios. Another thing, make sure to save the date. Next week on Thursday, there's going to be a .NET Conf event focusing on F#. Now, why does this matter is that there's going to be actually a lot of discussions on data science and machine learning. So you're going to want to make sure to check those out. If you go over here to check out the agenda, you get to see some of the sessions that are going to be taking place. You're going to see that there's this productive data science in biology by Kevin Schneider. We're just going to skip over, but I'll be doing a session as well on data analytics and machine learning. This one's actually going to be super interesting. So for folks who may not be familiar, Guido Van Rossum, he's the language designer for Python. And Don Syme, who's the language designer for F#, is going to be teaching him a little bit about how to use F#. So that should be a really fun one. There's another one on mathematical planning and some libraries from the FS. I suspect it's going to be showcasing some of the FS Lab set of libraries and a few others. So just make sure to tune in and save the date and join us next week. There's this other release that happened. So if you've been keeping up with sort of .NET 6, which I believe it's going to release in November, Preview 6 was just released a few days ago. Now, the thing that is super interesting to to ML.net or to machine learning is this section here. As of Preview 6, .NET 6 supports OpenAPI, for minimal APIs. And also it allows for a cleaner syntax when working with, when injecting services through the methods, right, inside of your handlers. So the way that that looks like, and if you're not familiar with minimal APIs, it's basically a way that you can leverage some of the latest C# features to instead of having to create, let's say, a controller and having to set up a startup file and doing all these things that you normally would do with web APIs, right? This process significantly cuts down on the amount of code that you have to write. That way, you're able to focus on, the core logic of your application. So it cuts down on the boilerplate code that you would have to write otherwise. And this is especially useful for those scenarios where you need those super lightweight microservices. And for machine learning, right, that's certainly the case, because all you need is a single endpoint to handle making predictions, right? So the way that you do that, it's just the same way that you would go about adding Swagger, the Swagger UI to your ASP.NET Core applications using the Swashbuckle ASP.NET Core NuGet package, right? And then a lot of this looks very familiar or very similar to sort of the way that you would go about adding Open API support for your ASP.NET applications. And that's kind of what the UI looks like. And then that from services sort of syntax, right? You can notice here that instead of having to add the attribute from services, now you can just directly inject your services. This is extremely useful for the prediction engine pool, right? So the prediction engine pool in ML.NET leverages dependency injection and is used inside of the respective handlers, and it's injected as a service. So, if you can cut down on the amount of code that you can write there, this looks much cleaner, in my opinion. So yeah, make sure to check out .NET 6, Preview 6, and take it for a spin. I believe the team is also, has started exploring, now that Open API support is supported. Now that Open API is supported inside of ML.NET, that means that these productions, or the template, if you're not familiar, when one of the latest model builder releases, right, what was part of that release was essentially the ability for you to scaffold a web API to consume your model that you create with Model Builder. However, the difference with that template and this one is that with that template, it's using this other technique known as route to code, which the trade-off there is, although you're getting minimal code, you can't do things like injecting services. You also don't get Open API support. So by leveraging this minimal API ASP.NET service, you sort of get a more production grade type of application. So be sure to check that out. Something else, John Wood, he basically put out a video recently talking about some of the latest changes in ML.NET 1.6, right, which is the latest release. So if you prefer watching a video, this kind of condenses into 6 minutes what's in the release. Right. And with that, let's take a look at this new release, ML.NET 1.6, and just chat about it. Let me sort of bring you guys back in. There we go. Awesome. Yeah, so maybe we can just have like an open discussion on, what was released in 1.6. And folks, if you have questions in the chat, or, you have feedback or anything, let us know, and we'll make sure to bring that up here as well. I know a lot of people were excited. That's why this one's sort of up top here. And, the team has been working hard to try to get this into ML.NET, and I've seen some feedback from folks on Twitter that they're super excited about this. So I guess if anybody in the chat has gotten a chance to try it out, maybe build Xamarin or Maui applications, can you tell us sort of what you're building and what your experience has been so far?
Yeah, and I think even like we have GitHub issues back from 2018, right when we released ML.NET in public preview, like asking for ARM support. So I'm super happy that we were, only took us a few years, but I'm so happy that we were finally able to add that and really become cross-platform, as we kept saying that we were. Right now we truly are. And I do believe there's a few limitations which are listed here and in the blog post, but I think most scenarios would be supported. If there's a scenario that's not supported, that you all that are watching, want to see, let us know. We can see if there's any workarounds for that. In the blog post, it talks about the limitations a bit more. I don't know if it's in the release notes, but yeah, if those limitations are blocking for you, let us know, and we can look into that.
Yeah. I mean, I know this one, and I don't think that it's here, right? Or it doesn't specifically call it out, but also Blazor. That's also another one that it really it sort of expands the capabilities of Blazor, Blazor WebAssembly specifically, right? I remember it was a similar. I remember feeling the same way that I did with ARM, where when ML.NET first released, and mind you, that Blazor at the time, I think it wasn't really a thing either. But as soon as Blazor came out, and especially Blazor WebAssembly, so being able to do everything on the client, I was like, cool. It would be nice to just do everything on the client. Now, there's some reasons why you might not want to do that, but the point being that there's this new sort of application way of building applications. Since ML.NET runs anywhere that .NET runs, can we get this running on Blazor WASM, right? And I think with 3.1, there were some limitations there. That's .NET Core 3.1. There were some limitations there. But then with the introduction of .NET 5, sort of a lot of those limitations, especially for using your model to make predictions, sort of went away. But there were still limitations with .NET 6, right? Now, those capabilities of being able to train sort of expand, right? And now you can see that ML.NET almost gets, just by the latest releases of the .NET SDK, ML.NET automatically sort of benefits from those things, and Blazor WASM is one of those.
Yeah, and something else I want to call out about this release, I think we had, I can't remember exactly how many, but a ton of community contributions to this one, community PRs. And I think they're all, and
Yeah.
I think we list when it's a community PR, we add them and thank them there. So thank you to everyone who contributed, and also hopefully this is encouraging for others who are watching. We welcome and love contributions, also just feedback, of course, and questions. And if you run into any bugs, but PRs are awesome to see, and seeing the community engaged with us. So if you do make some contributions, we'll definitely shout you out in the next release notes and blog post.
Yeah, no, that's totally right. And the one that I know specifically was this one. So being able to save TensorFlow models in the same model format. I think that there's two ways. And if I'm not mistaken, the original way was using this sort of like this protobuf type file, right? This protocol, like the way that it was serialized, that's the way that originally you were able to do it. But then TensorFlow also has the same model format, and it seems that Darth Vader here added this way of saving models. And Darth Vader, I believe, also made a few improvements. Yep. So one is being able to speed up the inference on TensorFlow models, and the other one is speeding up the bitmap operations on images, right? And I think you can go into more details here in terms of, I think there's some descriptions on and benchmarks on by how much does this, do these improvements speed up, these respective operations. But, Darth Vader is just one of the contributors. You can see that there's a whole bunch of them who made this release happen or helped make this release happen. So yeah, huge shout out to them.
Yeah, anything else you wanted to call out from here? Or?
Not that I can think of, no. There is this other thing here, which I don't know if folks may be familiar with, which is the data frame API. And a few months ago now, so the data frame API, you can think of it kind of like, a Pandas data frame, right? But for .NET. A few months ago, that used to be sort of its own separate project, but it's since been merged into the machine learning repository. So the ML.NET repository. And as a result, you're going to notice that there's going to be a lot of call outs to these data frames. So that's another interesting thing that, in addition to the core of ML.NET, you also have this data frame, way of representing data that also keeps getting improvements. So I think that's important to note as well. And that experience just keeps improving.
One thing to add to that is with data frames, it kind of works better in a notebook experience. So we have a previous .NET Interactive stand-up you can watch, but the data frame APIs make it so that your your notebooks are a little bit easier to manipulate and work with, and have less, concrete types, making it feel a little bit more notebook native. So if you do love notebooks, check out the new DataFrame API and see how you like that in notebooks.
And Jake has actually been working a lot with notebooks recently. Do you want to tell them a little bit about the work you've been doing and what you've been able to accomplish? You want to talk about that yet, or do we wait till the next one?
Yeah, I can try. No promises yet, but we're working on a notebook prototype inside of Visual Studio, so that you can, kind of pull something up just like in VS Code and work with notebooks. But the reason why we wanted it in Visual Studio is because we already have that model builder experience for training your model. We want to, help you, basically take that trained model and all the code for training it and consuming that model, and generate a notebook and start, introducing you to some of the other features inside of ML.net. Things like permutation feature importance were very difficult to use. We're also working on improvements to make those easier to use. But that's one example where, it's hard to figure out how to use it from scratch. But if we give you sort of sample code, it's sort of, a light bulb moment. It's kind of easy to use once you have something working. And so we're hoping by basically bridging the gap between Model Builder and notebooks, we can start to show you off some of the cool features in ML.net specific to your data set and your models.
Yeah, and Jake's been working with the .NET Interactive team, and they actually have a kind of prototype working in Visual Studio that I've seen. It's really, really cool. So I'm excited to continue work on that and get that out there eventually and start getting feedback. But when we did some user studies around notebooks, .NET Interactive Notebooks and ML.NET, and we found out, we kind of had this, we call them hypothesis about, we think people will want, to use notebooks in Visual Studio. Well, the real thing that we discovered is people want to use notebooks if they want to use notebooks. They want to use it in their primary editor IDE. And of course, .NET developers tend to be in Visual Studio. So that's kind of what it's not super surprising, but, just something that we kind of validated through user testing there. So I do see a few questions in the chat. So Jim here asks, can machine learning be used to capture and filter SMS messages? Does anyone want to take that one, or?
I suppose the short answer is probably yes. I don't know if carriers give you access. I think Mr. Mark West here kind of provided an answer as well for you, Jim FYYC. Yeah, I don't know if your carrier will give you access to those text messages. But if you do have some way to access those text messages, you could certainly filter them. And by filtering, I'm not sure if you're referring to I don't know, you often get those, well, I don't know, at least in the United States, one of the things that you get is have you, your car insurance is expiring, you get those robocalls and those sort of spam messages. So if it's, filtering for spam and things like that, you can certainly use machine learning for that. If it's just filtering for the sake of filtering, I think that machine learning may be generic filtering, that may be a little bit, too much, and you might not necessarily need machine learning for that. But if you need something way to automate route messages or do things like that, machine learning might be able to help.
Yeah, and it looks like some people are adding some suggestions here. Mr. Mark West said that some folks are using it for filtering Twitch chat messages. So yeah, I've seen that quite a bit. And someone else, Gregor, wasn't it, that did it for Twitter DMs? He did for the ML.NET hackathon.
Yeah.
Has a great video on it. Maybe we'll find the link and put it in the chat. But he was using ML.NET and machine learning for filtering, inappropriate messages that came into Twitter DMs. That was really, I think it was a Chrome extension, right?
Yes.
That was super cool. Yeah. Flurry of Activity said that they would create a stream of SMS messages and then operate on that stream with ML filtering. Yep, that seems to be the right way to go. Someone else, and then Jim said capture data points and put them into a SQL database. So a few ways you could approach it. I mean, you could definitely use machine learning for depends what kind of filtering you want to do. But yeah, it's definitely possible. Yeah, and then there's also F1 data analysis in the ML hackathon. That was a really cool one as well. Maybe Louise, do you have a link to the hackathon projects and that we can
I can
send everyone? Yeah, those are really, really cool. There was one on, I think, wine, where you would put in a description of what you would want in the wine, and then it would suggest a wine for you. I really liked that one. Yeah, they were awesome. So those should give you a few ideas of what you can do with machine learning in general, and ML.NET, of course. Any other
Yeah, one of the things that I
questions?
think you sort of touched upon was, the model explainability component in notebooks. And if I understand correctly, the team's been also looking at that and perhaps even, helping make the API a little bit easier to consume.
Yeah, so Jessie, who was on, I believe, 2 weeks ago, the last one, she's been working on model explainability, talking to a lot of customers, proving that our API or for PFI, which if you haven't heard of PFI, permutation feature importance, it's saying, when you're making a prediction, which features contribute the most. So if you think of taxi fare prediction, the distance traveled is going to affect the final fare amount versus the number of passengers a lot more. So, we kind of did some studies and talked to customers showing, hey, the API is not the easiest to use. So we're working on making improvements to the API. Also, Louise has been working on improvements to documentation for that. And then Jesse's also starting to outline some more like additional model explainability features that we want to add to ML.NET. So for model explainability and fairness, so take a look at that stand-up from 2 weeks ago to learn more about model explainability in general and some of the things that we're working on. And we'll have probably a more detailed plan in the near future as she continues to talk to customers and inform that plan. And then, as Jake said, with model explainability comes visualizations and graphing, and that's where notebooks will really help out there too. So yeah, that's some of the model explainability stuff we've been doing. We're working on quite a few things in tooling, a lot of exciting things, too many things. One of the really cool things that's top of mind for me is internally we're calling it continued training. I don't think we'll call it that, but essentially, I don't know if any of you have ever used Model Builder and you set it for 10 minutes. That's not even that much time, but you set it for 10 minutes and then you don't find a good enough model. Well, in the case of continued training, you'd be able to, the history of training is saved and you'd be able to continue on with training different models from that last point and add more time to training. So that's something else that we're starting to work on. What else, Jake? What do we have in the pipeline?
Well, just to add to the continued training, it's partially motivated by people that are first time using Model Builder and our automated machine learning tools don't really know what time to specify. We got that feedback a lot in our customer development. We also get it, issues in our repo quite a bit saying, why did I not get a model after training for a certain amount of time? Part of that is, with AutoML, there's lots of variables. It's hard for us to know exactly how long it's going to take to train. We don't really know how long it's going to take to train one model, not to mention, converging on the best models. So we're trying to, potentially shift how we communicate that to our users, right? Instead of saying, train for X amount of seconds, you could say, train one model, train 100 models, train until you get to a certain accuracy. And so we're exploring options there so that instead of, using this one unit that doesn't really work for either the customer nor us on the development side, we're exploring different options there. And so we're working to see what we can come up with. We're also working with MSR to figure out, how we can keep improving on our AutoML. So right now, we don't really have smart starting points, and so we're working with MSR to figure out sort of smart starting points, kind of analyzing your data set and seeing if there's maybe some shortcuts we can take in AutoML to get you to a good model faster based on your column types, just sort of generic characteristics about your data set. What else do we have going on over there?
Yeah, that was going to be one of my questions. Talking about trying to find what might be a good indicator of when to stop or when to sort of setting those thresholds, right? And maybe the role that things like NNI and the AutoML, the different ML implementations in in ML.NET and Model Builder can help with that? Like, what's that sort of role, and how is AutoML playing a role there?
So we're still trying to figure that out, because I mean, it is possible. Like, the hard thing is that when you give us a data set, it's possible you give us a data set that doesn't have correlations between the data to do the predictions you want, right? So you can't just say like train to 95%. It's a little bit more nuanced than that. So we're working with them. We're also getting some good customer feedback saying that they want more control and involvement in that process. Like, they want to be able to see, when it's training, are we sort of overfitting? Have we stayed, stagnant at 80% accuracy and we're not improving anymore? Those would be good indicators that you're starting to overtrain, or that our search space isn't good enough. There's lots of things that might be going wrong there, but we're looking into it. So yeah, I mean, I think we've got lots of fun avenues we're exploring for machine learning, for AutoML specifically. But another thing we're battling with is, as we have these options, we've often been thinking of Model Builder as our easy getting started tool. So we're trying to figure out the best way to make it a tool that's still easy to get started, but now is starting to have some of this advanced functionality. Even things like model explainability, us giving you 10 graphs trying to tell you how well your model is working or how it works may or may not be, the information that you need to keep, get started your first time. But once you have a model and you've integrated into your application, then you might start wondering, how do I know if this is the right model, or if I need to train more and stuff like that. So we're exploring, first time experiences versus advanced users versus things like that. So if you have any feedback and, maybe what you are getting or not getting from Model Builder, or what you would want in Model Builder, definitely give us that feedback, and we'll try to figure it out.
It's definitely a fine balance of keeping the simplicity and then offering all the features that our advanced users need, within tooling, because it's just, we keep getting the feedback when people first use Model Builder, like, oh, this is so straightforward. I think straightforward is the most used word, and we don't want to, get rid of that, right? So, and then, something we've been talking with our designer about is, well, maybe we kind of hide a lot of these things behind advanced options, but does that make sense if, we have a ton of different options that are hidden? And apologies for the dog in the background if you can hear that.
They agree.
Don't worry, that's not Malibu. So yeah, so it's definitely a fine line there. And some of the other things that we're working on is, being able, so right now we choose which evaluation metric picks the best model. So for classification, whichever model has the best accuracy, that's the model that's chosen. For regression, whatever model has the best R-squared, that's one that's chosen. Well, we're working on adding the feature to Model Builder where you can choose which evaluation metric you want to choose the best model. So we don't, we'll have a default, but then you can override that and choose which one you want. Another one is, right now we default to you just put in one data set and we split that data set, or do cross-validation. Well, we want to enable you all to be able to choose the split that you want within the data set, or even be able to add a second data set as your validation data set. So these are some of the things that we're working on, but at the same time, trying to figure out how do we keep Model Builder and the UI simple and clean, while also offering all these options. So, if you have feedback on that, or have features you want to see, or, have recommendations or questions, feel free to either post them in the chat, or obviously our GitHub is always open too. And we do have a question, I think that was pertaining to the training and data set size. So does machine learning prediction time depend on trained data size? So if you have less trained data, does that mean it'll be a quicker prediction? And if you have larger data, does that mean it'll take more time to predict?
Not necessarily. I think it depends more on I think there probably is a correlation, but depending on how big your data set is, whether in terms of columns and number of rows, that might lead to a more complex model that we choose to use in AutoML to get you a better accuracy. So the fact that it is a more complex model means that it may take more time to predict. That being said, I haven't done any of the performance analysis to know how much of the time is spinning up the the process, loading the classes, loading the libraries versus actually doing the prediction. I don't know if it's going to be a significant time difference depending on that one variable of data size. But I feel like there is probably a correlation there.
Yeah, and maybe the other one that I think the other way to think about it as well is like whether you're doing a single prediction versus like batch predictions, right? So in that case, if you have a single prediction, obviously it's going to take not a long time usually. But then if you're doing a batch prediction, right, it's dependent on the size of your data set that you're predicting, how many instances. Yeah, and Michael here sort of chimed in the chat as well. It is correlated to the number of features that you have, and that would make sense, right? Like instead of performing operations on say 3 columns, now you're doing it across maybe 1,000. You would expect that it would take a little bit. It would take a little bit longer.
Right. And if you think of what a model is, right, it's kind of the pipeline of the transformations and the algorithms that are going to be used. So if there's more transformations, more features that it's going to be doing it on, it's going to be kind of a large.
I think Bree may have froze.
Oh yeah, it's lagging. It's in slow-mo. So while that's while Bree finishes her sentence, we can maybe check out Surash's question here, which is there something similar to Model Builder in terms of UI in a Blazor published app? So what I imagine or what I infer, and maybe you can clarify, Surash, what you mean by that, but what I'm guessing your question is there a web app like Model Builder? Can you access Model Builder or a Model Builder-like tool through the web? And the short answer to that is going to be no. There is not. However, I do believe one of our community members in the Microsoft MVP, JK, may have been trying to do something like that. So basically, leveraging some of the AutoML API functionality and building out a Blazor sort of application that would perform the training very much like Model Builder. I think that they've done something like that. So if it's something that you're interested in doing, you by all means, I think you should be able to do that. And in fact, now that there's improved support in Blazor, specifically Blazor WASM, right, to do training with ML.NET, then I suspect that process might be even that experience might be even better, right? And you might have more support for more training scenarios. Also, if the other thing that I guess I'll call out is that if you're looking for like and I don't know if it's been updated, but there's a VS Code. So for example, Model Builder is for Visual Studio only. So that means Windows only. So of course you could also use the CLI for that sort of cross-platform experience. But let's say that you wanted a UI on top of that CLI, right? You could leverage an extension that one of our community members built, and we actually had him on one of the earlier stand-ups talking about it, which leverages the CLI. Now, the only thing with that is I think it's still using the old version of the CLI, so I'm not sure if that has been updated. But that's just another way that maybe you could get a UI in a non sort of Visual Studio or non-Windows environment.
Welcome back, Bree.
I'm back. Sorry, I guess my internet went out randomly, so I'm on my hotspot now. We'll see how this goes. Hopefully, I didn't miss too much.
I think it's just overall the stream is a little slow.
Oh, okay.
Yeah.
That wasn't just me.
If there's anything like, hopefully we're coming through to folks okay.
What question were we on, or what did we just answer?
So we just answered, and I think. Yes, go ahead, Jake.
I was going to say we were just chatting about Blazor WASM and training and its feasibility.
Awesome. It looks like Louise's picture is a bit jumpy and my volume is low. Yeah, sorry about that. My mic was giving me issues. So I literally have it here, but it's just not. Today's just a weird weird day. So apologies all for that. And of course, Jake is okay on both.
Yes. Last time I was the one crashing, so that's why I'm kind of celebrating a
Yeah.
little bit here. But
Well, funnily enough, Louise just left, so
I don't know.
that's okay. Did
Well,
we answer this yet?
yeah, I mean, I think that the main thing with Blazor, and I think why it excites people, is like you get to, harness the power of HTML and JavaScript for your experience, right? Which is just really easy and fast to iterate on, versus WPF or something like that. So I think that's why people are excited about it, is they get to sort of have that move fast, create fast, break fast web style programming attached to machine learning. But I do agree with your next comment saying, it's CPU, GPU intensive. I think that, kind of touching on what Luis said, kind of maybe the best of both worlds would actually be to use the CLI, which is, .NET, and can harness your full CPU and GPU. And then you could still, talk to that from a web application using something like Electron or something like that.
Yeah, and the other thing, right, is at least for training purposes, it definitely, I think it's okay, right, to have that sort of Blazor WASM, maybe not from a performance standpoint, but just, something that I can think of is, like, I don't know if they still have it, but I remember a few years ago, TensorFlow just had this sort of playground, right? And it was this web app where you used to, like switch some dials back and forth, and that would change how you would train your neural network with TensorFlow, right? So for those like maybe learning or from, relatively small training type of scenarios, just to get folks started, very much like Visual Studio's Model Builder, it's certainly okay. When you're scoring, though, and when you're using Blazor, specifically Blazor WASM, because everything is just downloaded onto your client, right? For inferencing, there's definitely security considerations you need to have there, right? Because your model is literally being downloaded down onto the client. Maybe that's not something that you want to expose, all right? So there may be some security risks there. But for training purposes and for learning specifically, it might be a really, really great tool.
So I can touch on this. I mean, totally. Like you could, in like a web app or, a console app, WPF app, anything, have training pipeline code in there. There's a subcategory of models that I just recently learned about called like online models, where it's literally training itself as new data comes in. We don't really have anything like that in .NET yet, but if you have some scenarios for it where like, your data is changing, I think I'm basing this off of one conversation I had, but I think, if there's lots of data drift day to day, right? Or if there's lots of change day to day where there's sort of a recency bias in your data, then online models can be extremely powerful. But yes, it's totally possible that you could do that. And we've also, I think, heard of use cases where people want to train custom models per each user. So that way, like if a new user comes on and they have data, you would want to train a very specific model for that user, and you could totally do that too. So it's definitely feasible, and there's use cases for it.
Yeah, we've got a good question here. Does the pure single-threaded nature of WebAssembly not present an issue with machine learning models that can utilize concurrency?
So, yeah, I mean, it would slow down. I don't know. Michael would probably be, if he's still on, a good person to answer if there's like any algorithms that specifically wouldn't work on single-threaded. But it would likely, slow things down for things that can utilize more threads.
Yeah, but I think, going back to our earlier conversation of, so you have Model Builder, right, which is supported, the team is actively developing it and things like that. But perhaps for your organization, right, or for your enterprise, you might hit some of those limits, kind of like what Brie was saying, where it's like, hey, we want to have this feature, or we want to have that feature, as part of my training process and my training workflow. At the end of the day, you could utilize the API and sort of, build your own, right? If you're seeing that, maybe there's something that you need to customize that, it's very niche to your training workflow and your training scenario. So in cases like that, right, you might be okay taking a bit of a hit on that performance with a Blazor-like experience. And by the way, you don't have to only use Blazor, right? You can do this in a WinForms, WPF app, other things as well, right? But the point being that you could leverage the ML.NET API to sort of build your own custom training environment, right? So yeah, so that's another, I guess, reason why you might consider, even though performance-wise it might not be the best, from a standpoint of, hey, this is something that I really need, and it's super specific to my scenario. Maybe in that case, it's a trade-off that you're willing to make.
Apparently, I'm very hard to hear, so now I'm screaming a little bit. But at least there's subtitles here. Maybe one of you two can read the question, because that's the most important part.
Yeah, so 5th of July says, where to start with machine learning, F# or F# and why? I'll hold my comments because I have very strong opinions on this, but yeah.
Well, I'd love to learn, what your thoughts are. But I think at least right now, oh, go ahead.
No, I was going to say both. They're both really great. With C# you get a lot of, support, first class support for a lot of the libraries, right? So ML.NET, TensorFlow.NET, Torch Sharp, all those set of libraries. You certainly can leverage C#, F# because they're both .NET languages. So my answer to you is use whatever you feel most comfortable working with. That being said, I have a strong preference for F#, mainly because if you're coming from like a Python background, right, F# is going to feel very lightweight to use. It's going to feel very Python-like, where it's super easy to get started prototyping. Whereas C#, it's getting, like with C#9 and C#10, it's getting less verbose. And that's feedback that we've heard previously, where it's like, oh, why do I have to write all this code with Python? I don't have to do this. So F# kind of gives you that in between, like that nice sweet spot where you're still in .NET, but it's super lightweight and super succinct. So you don't have to write a lot of code to do those same things. But at the end of the day, use whatever you feel most comfortable developing in. They're both great languages for .NET that you can develop machine learning applications with.
Have you used F# with ML.NET yet?
Yes, yeah. And we actually have a few samples. If you go over to our machine learning samples repo, there are a few samples that use F#. Cool.
Yeah, my personal recommendation right now would probably be C# to leverage everything in ML.NET. It's more supported from our side, but especially if you're using F# with ML.NET, I mean, I'd hope we'd still be able to answer most of your questions. So feel free to do that. We also have a prior community stand-up with Don Symes, going over some Torch Sharp stuff and some cool things that they were doing for like debugging features when building models with F# in Visual Studio. So there's some support there, but I would say that's more in its earlier stages of development than ML.NET. But you have options.
All right, we've got this question. Maybe again, someone else should read it out loud because my mic issues.
So yeah, which package would you suggest for NumPy, Pandas alternative, and C# or Link? We were actually talking a little bit about the data frame API earlier. I know it's not like a perfect match for what you're asking here, but I don't know. What are your thoughts, Luis? Oh, I think you're muted.
Yes. Okay, there we go. Yeah, so in terms of packages, I think the data frame API is trying to sort of fill this role to a certain extent. That being said, though, the data frame API is still in its very early stages. So there's still, a bit more work to, personally, to say like, hey, this is something that you could use in sort of for all cases, and it's pretty much 90, maybe 99%, what Pandas is to Python, right? So there's and the team is actively, they're actively developing it, but that's what I would say is eventually probably what it's going to be somewhere down the line, but just not at the moment. But I know that the C# folks have also had this NumPy, Pandas.NET type of package as well. I don't know how actively it's being developed, but that could also be an alternative as well. If you need, and I think, one of the, I guess, nice things, it might be a little bit weird as a .NET developer looking at some of the C# packages because they tend to have these Python-like naming conventions, right? But for folks who are already using Python and they want to use .NET, right? It may be like an easy transition for them to sort of, move over to those set of C# packages because it's going to feel very much the same as how they're currently using those packages in Python. So those would be my 2 recommendations there.
Just to add to that, I think we should probably take a homework assignment. I feel like that has come up quite a bit of like doing an inventory and seeing, what functionality we're missing. And, at the very least, creating that backlog and trying to get community engagement there to build it, or adding it to our backlogs and timing that out as well.
Yeah, and I think that Fuel and what you just mentioned, Jake, is actually a really good thing to consider. So Spark.net, yeah, or .NET for Apache Spark. That's also another alternative. So you have, and that's the thing with like, I don't know if there's been a better word that's come up for this, right? Maybe it's just because that's the best way to describe it. But data frame is an overloaded term. So in .NET for Apache Spark, you have data frames. Now, those data frames are specific to .NET for Apache Spark. You also have the data frame API, which is part of the machine learning repo, right? The ML.NET repo. That data frame is something different. That's more like a pandas data frame. So it certainly can cause confusion. That being said, though, because at the end of the day, they're doing the same thing, whether it's the data view, the Spark data frame, or the data frame API. At the end of the day, they're doing the same thing, which is just representing data in some sort of tabular format and a schema, right? Some way to like get these 3 talking to each other, where you can say like, idata view .to data frame, right? And it would just, convert it to a data frame, whether that's a Spark or a data frame API data frame, would be a really cool sort of, feature to have. And for that same scenario where you were mentioning, Jake, before, right, where data frames, they're really good for these interactive environments. But perhaps now when you get to your modeling phase and you want to train a machine learning model, perhaps a data view might be more appropriate for those scenarios, right? So being able to go back and forth between them, would at least help, right, in going from that sort of exploration phase, the modeling phase, and making that transition easier.
Yeah, something that we haven't talked about yet that we're working on the frameworks API side is deep learning. So we just talked to a ton of customers, a ton of people, all of you, and talked about, gathered some requirements for deep learning. And we can talk a little bit about kind of our initial thoughts there. So one, we want to make sure that our consumption experience is as easy as possible. I went through and saw that we have a lot of issues with Onyx consumption, particularly around like understanding the inputs and outputs. So that's something that we want to improve upon. We want to improve upon consuming Onyx models specifically. The other thing, so the second thing we're looking at is transfer learning. So right now, if you've used our image classification API, that uses transfer learning, and it's on top of TensorFlow.net, which is part of that C# stack that Louise was talking about. And so we want to expand support for different scenarios. And so far, we've been very scenario focused, right? Like I'm sorry, my face is so close to the computer. I just want to make sure you all can hear me. Can you hear me, by the way, as I keep talking? Okay. So we want to, we've been very scenario focused thus far. Like if you see Model Builder, it's like, you choose classification, value prediction, and so on. And that's to make it easy for, non-data scientists. So we want to kind of continue on that pattern and have these scenario-based APIs, so kind of higher level APIs for transfer learning. And if you don't know what transfer learning is, it's kind of a step above training a neural network or deep learning model from scratch. Instead, what you're doing is taking an existing pre-trained architecture deep learning model and kind of retraining a few of the layers to be more domain specific for what you have. And so we have that, like I said, we have that for image classification and our image classification API. We want to add one for object detection. We want to add some for natural language processing or NLP type things. So that will be, again, very high level scenario focused, but then for scenarios that might not fit like within those scenarios, we want to have, we're thinking of having a lower level API. For one, if the scenario doesn't fit. Two, if you want to dig deeper into the lower level and have a bit more control and not be as abstract. So you're able to do transfer learning that way. The next task, which is a very big task, is being able to train neural networks from scratch in .NET. So that's something that, when we were talking to users was really big, is that they said, my scenario does not fit in with either consuming a pre-trained model or the transfer learning scenario, and I want my whole end-to-end workflow to be in .NET. I don't want to have to deal with Python. There are people who even were using Python-based frameworks, and they're like, yeah, it works for my scenario, but if I could have it all in .NET, like that's what I want. And so that's something we're looking into as well, and we're really looking into leveraging TorchSARP, which Nicholas Gustafsson is someone we work with quite a bit. He's a PM architect here in DevDiv, and he's been helping out, helping define the deep learning strategy, and he makes a lot of active contributions to TorchSARP. So TorchSARP is probably something that we'll leverage when we're working on our deep learning story. So yeah, sorry, that was a lot of, Jim said it's a lot of jargon. So deep learning is not really a catchphrase. So I wish I had the infographic up. So you have artificial intelligence, and then you have machine learning. So artificial intelligence is just like a computer acting like a human, or reasoning like a human, doing logical thinking like a human, like what a human would do, saying, is this a hot dog or not a hot dog? If you've seen Silicon Valley, you'll get that. So, but in artificial intelligence, you could use a list of if statements, and it could go on forever and ever and ever, right? Like, how does the computer know what a bun looks like or whatever? So machine learning then is a subset of artificial intelligence where you're taking past data, like to train a model to find patterns in that data, which you can then add new data into to make new predictions on new data. So you're using historical data, past data, you're training a model, you're using it out, finding the right algorithm. You have this model that you put in new data and make predictions. Deep learning is a subset within machine learning. And I'm sorry I don't have visuals here for this, but which kind of mimics the neural networks of the brain and is more, a lot of times it's based on images and yeah, it's a hot dog versus racetrack. And it's just, yeah, it's a subset of machine learning that's a bit more, I wish I had the picture. Do any of you have pictures to show, like info, like graphs? It has like layers of networks.
I'll see if I can pull something up.
Yeah, it is a lot easier to explain. I'm just kind of rambling on here, but that's kind of, so, well, it is kind of, a catchphrase, not really. It actually is a subset of machine learning.
From like a technical perspective too, it's just like a completely different stack, right? So it's two different approaches. Like you can oftentimes, going back to like our scenario approach, like you can solve a lot of the same types of problems using the two different tech stacks, but like they are sort of, two distinct approaches to using, machine learning to solve your problem.
Right, and Luis pulled up the.
Yeah, so not sure, this probably doesn't help, but essentially like what the neural networks are, they're just like stacked learners, if you could think of it, right? Where each stack is just the output from this one becomes the input into this layer here. And then this layer, all it's doing is, acting as a classifier and saying like, 1 or 0, yes or no. So they're just stacked. You can think of these like models themselves, like mini models themselves that are stacked on top of each other, where each sort of stack has its responsibility of looking at like a particular piece. So for example, if you were looking at an image, right, and you were trying to detect a face, perhaps one stack may be focused on, saying like, is there a nose in the image? Are there eyes in the image? Things like that. And each stack would be responsible for that. So it's just a stack of little models, if you could think of it that way, right? That as a whole act to say like hot dog, not hot dog, or, face, not face.
Or bread or pug.
Bread or pug, my favorite one.
All the time. So hopefully that kind of helped and didn't confuse you more, Jim. And we can always have going back to the basics of ML stand up. We've had quite a few. We might already have done that. So, but we definitely have a few sessions we've done that we do the intro to ML type stuff.
Yeah, which brings us, let us know if it's something you'd like to see. We've been thinking about this concept of, I don't know if you folks, remember or maybe familiar with like Sesame Street, where like they'll have like a word or like a number that they'll bring on the show, and it'll be like, this show was brought to you by the letter A or whatever. So, talking about some concepts, let us know if that's something that would help. A is for algorithm, exactly. And
We
talking
could probably
about
have about 100 A's though.
right, accuracy. Yeah.
And then we'll cycle back through, after.
Right.
So we did have a question here. Where is it? I want to start machine learning. Where do I start from? Any good resources for machine learning?
I have a very biased recommendation of download, Model Builder, try out Model Builder. I think that, hopefully we do a good job of breaking it down into scenarios so that you don't have to dive too deep into the complexities of all the different algorithms. And you can just go from, I have a problem, I have something I want to predict, to code that you can integrate into an application. So I would start there. And then once you sort of, at first just treat it, like a black box of, I'm trying to solve this problem, get predictions, see how you can integrate it into your applications, and learn a little bit about, what sort of problems it can solve. Then there's tons of information you can dive into after that, depending on which way you want to go. So that's my recommendation.
And it depends like how much about machine learning you want to learn. Like, do you want to learn what each algorithm does and what it's good for? Like, that's going to be a bit more involved, right? Versus what can I do with machine learning and how can I build that in .NET? So it really does depend what you're trying to do with it and what you want to learn with it. Yeah. That was kind of a non-answer, and I apologize.
Yeah, and I can't speak I can't speak for for everyone else, but I think just in general, like project-based learning really goes a long way, and I think Model Builder can help you do that, right? Where it takes you step by step through each of these scenarios, and later on you can go back and check out the code to see like, okay, well, how was this actually done? But just like think of something that you want to solve. I don't know, predict taxi fare. I know that's one we always do and show off just because it's a bit simple to reason about, right? But just think of something that you're trying to solve. Maybe you can get data sets from Kaggle or the UCI repository. Those data sets are a little bit more they're kind of real world, but they're also clean enough that you're not worried about missing values and having to clean up your data. So those are some really good ways to start as well. Just project based. Think of something you'd like to solve, find a data set, and use Model Builder to see how far you can get.
We've got another question here. Is there a way to directly save a trained model to SQL database or to an Azure Blob storage? An Azure Blob storage.
So there was there was a topic that we haven't really gotten to, which is we're also exploring like what does it look like to train models in like a CI/CD or DevOps or just like a retrain or like Git type environment, and we're still working to kind of figure out what that's going to be like with ML.NET and how are you going to train and stuff like that. So I think there's the one piece here, which is, do you actually want to train in Azure and then have that end up on a blob storage? We're still working on that story. If you just want to train on whatever machine you have and then publish it to a blob storage, that we can definitely help you out with. There's lots of libraries out there for uploading. One that I would probably, I won't dive too deep into it, but if you can create an issue in our repo, happy to kind of give you some pointers on how to train and upload it. We don't have anything native in the ML.NET library right now for publishing to blob storage, but if there's interest there, that could be a valuable sort of extension library we could create.
And then I think this has to do a bit about like model deployment and ML ops, so and integrating back into CI/CD. So Dr. Einstein von Brainstrom says they've been using ML Studio, and Dr. Einstein, you're going to have to clarify because we were talking about Model Builder. I'm not sure if you're talking about Azure ML Studio or Model Builder, but so been using ML Studio, really love it. Just wanted to know if it's possible to hook it up with a service bus to trigger training based if my new data set hits a limit size. Say I want to train once my new data hits 5 gigabytes.
So we're looking into this. I know that they're like, they being the Azure ML team. I'm not familiar with the term ML Studio. I'm not sure which product that is. But the Azure ML team is having a concept of train job that you'll be able to do lots of different triggers on coming soon. So I know that they have specifically mentioned like service bus and other sort of triggers. So it should be possible. I'm not sure what all that is right now. Luis, do you know for that specifically if it's?
No, I'm not too familiar with, and that's terrible because I kind of work on that. But I don't know specifically if there's a built-in way to do this. Of course, if you do it manually, yeah, that's totally possible. But that's built in. I don't think that's something that you can do out of the box. Yeah, but yeah. So I guess I'm not aware of one. And then, yeah, I see Fuel here is trying to do a project to find optimal stepping site for ray marching given a distance field. So that may be a little bit more than a beginner sort of getting started project Fuel. But yeah, I suppose I personally am not familiar with ray tracing, but I suspect that machine learning can help with that.
Yeah, I think we've answered most of the questions, and we are at time. So we always come into office hours. We're like, oh, maybe we'll get a few questions, and we'll have a half hour, and then we end up just talking forever. So thank you all for keeping us engaged and being engaged yourselves. And unless do you have any closing thoughts?
No, thanks everybody for joining. As always, if you have any more questions or comments or feature requests, join us on our Git repos and post questions there, and we can keep the conversation going there.
Yep, thanks a ton, and we'll see you in 2 weeks.
Cool. See you then. Bye.